Well, welcome to our last lesson in Unit 3 on solving compound inequalities. In this lesson, you're going to be solving compound inequalities in one variable. You will also be graphing the solution sets of those compound inequalities. So to begin, let's define what a compound inequality is. And basically, a compound inequality is just combining two simple inequalities into a single statement using either and or or. So let's get more specific on what we mean by combining these statements. So there are four different kinds of combined inequalities to give us compound inequalities, and these are demonstrated here and on the next slide. And so let's go ahead and explore what they mean specifically. For example, in letter A, I have x is greater than 2 and x is less than 6. If we were to graph each of the solutions to those inequalities, okay, x greater than 2 would look like an open dot on 2 going to the right. X less than 6 would be an open dot on 6 going to the left. So if we wanted something that was x greater than 2 and x less than 6, in order to satisfy that it had to be both these solutions that were greater than 2 and less than 6, we would end up with the solution set would be the numbers that are in between, but not including the endpoints 2 and 6. So we would have the solution set would be anything greater than 2 and less than 6, and it would be just the numbers that were in between there. So that's how you would graph the solution. Okay, on letter B, if we have x is greater than or equal to 2, it's very, very similar. We're going to have a closed dot on 2. X is less than or equal to 6 is a closed dot on 6. Greater than or equal to 2 and less than or equal to 6, again, is going to be the intersection of those two. And it will be all the way from one to the other. Whoops. Something like that. So that would be the solution set for those solutions. Letter C, x is less than 2. Okay, that one's going to be an open circle and going to the left. And then x is greater than 6 will be an open circle going to the right. So the solution set for that one, I'm running out of space there, so we can move that over. There we go. Will look exactly like what I have drawn there. You're going to have open circles on both endpoints, and then your arrows would be going outward. Okay, something to this effect. And then lastly, in letter D, we would have closed circles on both 2 and on 6. Okay, and again, less than or equal to 2 would go to the left, so that's going to go leftward. Whoops, don't want the red one, I want the blue one. Going out to the left, and then going to the right for greater than or equal to 6. When it's or, it's the union. When it's and, it's the intersection or where they overlap. So those four kinds of inequalities, here they are described in a table format. X greater than 2 and x less than 6. Whenever we have an and statement, we can write it as a single statement where the variable is in the middle. So similarly, here's the and statement with this one. And here's what those graphs look like, just like we got in the last slide. And then the or statement slides, you cannot combine those into a single statement. The or compound inequalities will always be given as separate statements, but their graphs will look like that. All right, so compound inequalities that have and statements. You can graph the solutions of a compound inequality that has an and statement using the idea of overlapping regions. And that's just like what I demonstrated in that couple of slides ago. The overlapping region is called the intersection, and it shows the numbers that are solutions of both inequalities. So the solution set is the one at the bottom here. Okay, so we have x is less than 10, x is greater than 0, but the solution set where x is less than 10 and greater than 0 is only the solutions between 0 and 10 and not including the endpoints. Every solution of a compound inequality involving and must be a solution of both parts of the compound inequality. And if no numbers are solutions of the simple inequalities, then the compound inequality has no solutions. So let's put some of this into practice. So it says solve each compound inequality and graph the solutions. So we have x is greater than or equal to 4. Whoops, excuse me, it's x plus 2 is greater than or equal to 4, and x plus 2 is less than or equal to 8. So here's our compound inequality statement right here. And so the way we're going to solve that is we're going to break it into two simple inequalities and replace it with the word and in between. So if we want to solve each of those simple inequalities, on the left I would subtract 2. So I end up with 2 is less than or equal to x, which is the same as x is greater than or equal to 2. And I'm going to subtract 2 likewise to the other inequality, and I end up with x is less than or equal to 6. These add to 0, and these add to 0, right? So we want and in between there. So now if we're going to graph those solutions, we need to have 2 and 6 on our endpoints, 2 and 6. X greater than or equal to 2 would be a solid dot, and that's going to go to the right, greater than or equal to 2. And then we have x less than or equal to 6 will be a solid dot on 6, and it will go to the left. So we will end up with the solution is just all the values in between 2 and 6. Letter B, we're going to split that one up. Negative 5 is less than or equal to 2x plus 3, and 2x plus 3 is less than 9. So one of the ways you can look at this is just thinking about just cutting off part of the inequality. Okay, so if you cut off the part on the right, you have what I've written on the left. And then if you cut off the inequality on the left, you have what's written on the right. Okay, so that's how you're going to solve those. You're going to just run two scenarios. Okay, so let's go ahead and solve that one. So we're going to subtract 3 from both sides. And I end up with negative 8 is less than or equal to 2x. So now to get x alone, I need to divide by 2. And that leaves me with x is greater than or equal to negative 4. So let me rewrite that again. X is greater than or equal to negative 4. So I'm going to have negative 4 on my number line. And then on the right-hand side, subtracting 3, I end up with 2x is less than 6. Dividing by 2 gives me x is less than 3. So I'll put a positive 3 down there. And let's go ahead and graph our solution set. X is greater than or equal to 4. That's a closed dot. And greater than or equal to 4 moves to the right. X is less than 3 is an open dot on positive 3. And less than 3 goes to the left. So we will end up having the solution set where we have an open dot on 3 and a closed dot on 4, and it's the stuff in between, because remember, this is an and statement. Okay, so let's take a look at compound inequalities that have or statements. You can graph those solutions using the idea of combining the regions. This is called the union of the sets, and the numbers have to be a solution of one or the other. So here's an example where we have solutions where x is less than 0. Here we have x is greater than 10. If it's an or statement, it's both solution sets together. It's the union of those. So the solutions of a compound inequality involving or are not always two separate sets of numbers. There could be solutions that are numbers that are solutions to both parts of the compound inequality. So let's do some practice with those. We have a compound inequality, and we want to solve it and graph the solution set. So we're going to solve these separately. So we're going to solve for a by adding 4 to both sides. And so we end up with these adding to 0, and a is greater than 5, or, again, we're going to add 4 to both sides. to get A alone, we end up with A is less than 1. Okay, so both of these are open dots, so we need the values 5 and 1. So here's the value 1, here is the value 5. Okay, and then we're going to have an open dot on both endpoints. So there's 1, and here's 5. Whoops, it's not letting me grab that. Here we go. So there's positive 5 and positive 1. Make sure to keep your numbers in the correct order on your number line. So this says A is greater than 5. So those will be the numbers to the right of 5. And A is less than 1 would be the numbers to the left of 1, like so. Solve the compound inequality and graph the solutions. So this one says that 2x is less than or equal to 6. So if we're going to solve this for x, we're going to divide both sides by 2. And we end up with x is less than or equal to 3. Or 3x is greater than 12. Dividing by 3 to get x alone, we end up with x is greater than 4. So we need the numbers 3 and 4 on our number line. So I'm going to put a 3 and a 4 on my number line. And x is less than or equal to 3. That's a solid dot because it has an equal to with it. Less than goes to the left. So those are going to go leftward like that. X is greater than 4 is an open dot on 4. And the numbers that are greater than 4 are to the right of 4. So that's what your solution set would look like graphically. All right, how about if we want to write the inequality from the graph? It says write the compound inequality shown by the graph. Well, on the first problem in letter A, our endpoint is -1 and we're going to the left, and then our endpoint is +7 going to the right. Since the shaded portion is not in between the two values, we know it involves an OR statement. So here's how we would write that. We have two inequalities. We have the numbers to the left of -1, so left is less than -1, but it has a solid dot, so it has an equal to. And then we have OR, again we have a solid dot, x is greater than or equal to 7. Okay, over on the right hand side, this time we have the shaded portion is between the two values, so we know it involves an AND statement. So this one we're going to go ahead and write. I'll show you how to write this in two different ways. Okay, so we know it is x is greater than or equal to 0, and we know it is x is less than 6. Open dot means just a less than. Closed dot means it has the equal to with it. Well, remember I told you we can write this with x in the middle. So it says x is greater than or equal to 0, but less than 6. That's how we would write it as a single statement. That will do it for this video. We'll see you next time.